Hey guys, my name is Nabil, and I've been tutoring and coaching for the SAT along with the ACT for wow, a little over 5 years now. I recently graduated from UT Austin uh, with a degree in neuroscience, so I'm pre-med, with plans to going into medical school. That's my plans, and with the SAT, now becoming digital, a lot of students, they're a little bit curious as far as how to, exactly tackle the math and the reading and writing section. Um, so I did have a session yesterday that was going over the reading and writing. Shout out to you guys that were there yesterday. Hopefully that was a very informative session for you guys. And so today we're going to be focusing on the math section. All right. And I will just be going over the fundamentals, exactly what you need to know to understand and deal with the math questions that you will typically see on the math section of the SAT. All right. And this could also trickle on over to the ACT as well. The ACT has a little bit of variances. But yeah, today we'll be focusing on the digital SAT math fundamentals. All right. If you guys have any questions, feel free to stop me and also direct your questions over into the chat as well. So yeah, uh, I'll be moving on over. So this session, so if you guys were in my reading and writing section yesterday, uh, uh, it was a lot of like, slideshow presentation, really just me talking. Um, Today, I mean, of course, I'm going to be talking a lot as well, but it's going to be a little bit more interactive in a way that I'll be basically using the whiteboard a lot and trying to work out some of the problems. Really trying to understand exactly what the SAT wants you to, to know whenever you deal with certain problems. So, um, yeah, with the SAT math, first want you guys to understand the thought process that you guys should implement when it comes to dealing with the SAT math. And there's a 5-step strategy that I recommend to all my students. Okay, and you can implement these for the easier problems, medium difficulty problems, or even the harder difficulty problems. But I really highly suggest this to basically have a system. That way, whenever you do encounter a really hard problem, you're just not stuck. Okay, you try to understand exactly what the question is asking, and then try to get an answer out of that. All right. So let's start off with the first step here. So try to understand what exactly the question is asking. This is like pretty straightforward, but oftentimes this is really the one step that I see students, earlier on in their prep process, they tend to struggle on the most, actually. Just really trying to understand the wording of the SAT questions, and uh, this really comes with more practice. Really, I try to guide students, with exactly, what the SAT wording is like, what they're trying to exactly convey. Okay, so this really just comes with more practice with step one. And then step two is identifying what do you know. All right. So what do you know? That really just comes with the fundamentals. All right, and really just trying to tie in exactly with what you understood from the question. Three, setup. This is pretty straightforward. Now that you know what you understand the question, you set up the problem. All right. And then four is solve. Um, so whether that be for X, any sort of variable you will solve. Now you may be wondering, well, why is five on there? Answer what is asked. Isn't that the same thing as solve? Well, I mean, certainly, but with four solve, sometimes it will ask for X. But then the question will ask exactly, well, what is X plus Y? All right. So it really, students will do a great job with doing steps one through four, but then they'll mess up with not answering exactly what the question is asking. All right. And Yeah, so really trying to implement this 1 through 5 strategy here is really key whenever you do all these math problems. All right. Um, okay, cool. Did everyone understand that 5 step thought process? That you should implement for all these math problems. And feel free to put some thumbs up in the chat. That way, I can see that everyone understands that. Yes, Tina, you had a question? Oh, okay, cool. No problem. All right. Yeah, so if we're good to go, then yeah, I'll move on over to the probability side. And let's see here. Yeah, so the probability and okay. So yeah, the probability and the combinations, these are usually a little bit more straightforward. Um, but yeah, so with probability, you're trying to find out exactly, what is given. All right. And I have this example here. So finding the missing value of the exam given an average of 5 exam grades in the other 4 tests. So let's just say, and I'll write this in the chat here is like, let's just say we have um 5 exam grades. Like let's just say like an 84, an 88, an 89, 90, and 91. And we are trying to, I'll put this in the chat here, and we had X and X. And we're trying to get an exam average of, let's just say, a 90. Okay, what is the missing exam grade? So, feel free to put in the chat, how would you try to solve this type of problem? You guys can feel free to, go into the chat, just give like a brief outline of what you think will be a good way to solve this problem, or even feel free to speak up as well. So I gave you 4 exam grades here. So we have an 84, an 88, an 89, a 91, and X. And we're trying to get an exam average of 90. So what is the missing exam grade X that we're trying to solve? I'll take a couple seconds just to wait on any responses here. And I'll basically just go over my thought process. Yeah, yes. And I like what Richard said. Um, yeah, so yeah, definitely try to make an equation of the 4 exams and the X. So something like this. One sec. I'll try to get a whiteboard going here. That way it's for math usually it's a lot easier to see this visually. Um to really get the concepts down. So I'll get the whiteboard going for this. So yeah, I'll stop the screen share and I'll share my whiteboard. Is everyone able to see this whiteboard? It's the online whiteboard. All right, everyone able to see it? Okay, awesome. So we got an 84, and then we got an 88, so plus 88, plus 89, plus 91, and then we got plus X, right? And then for an average, right, we would have to divide by the number of terms. Okay, so how many terms do we got? It's one, two, three, four, five. So we have to divide all this by 5. And then we have to set this equal to our exam average, which will be 90. Okay. That's a 90. Yeah, and then now since everything's divided by 5, we'll have to multiply by 5, so it'll be 450. And then 84 plus 88 plus 89 plus 91 plus x. And then you'll basically just subtract all this. And I believe it should be 88. Now, another way you could do this, and this is one tool that is implemented on the digital SAT that you could use is Desmos. So you can use Desmos. So I'll show you what exactly that looks like. Um, and you're also given scratch paper, so you could also do all this written by hand what I just did on the whiteboard. But I really want to show you guys also how to implement and use Desmos on the exam because that's a really cool feature um, that you guys can use on the SAT. So is everyone able to see my screen? It's the Desmos graphing calculator. Is everyone able to see that? So I'm basically just going to be rewriting the equation that we just made here. So it's going to be, um, basically we got the 84 plus, so 450. So yeah. So I'm just going to add up. So 84 plus 88 plus 89 plus 91. 89 plus 91. And we're supposed to subtract this from the initial 450. So 450 minus 352. Um, and yeah, this should get you to a 98 is what you would need um, for the exam average or for the exam grade, that missing exam grade, that X. And I'll share you my screen here. Um, will have to be a 98. So this was all equal to 352. 450 minus 352. This is all equal to x. X is equal to 98. Does that all make sense? So this is like a typical question that you may also see that the SAT may ask about, with regards to probability. Okay. If you guys have any questions, just feel free to, chime in the chat, also speak up. So, all right. So yeah, this is a probability. Another thing to understand with probability, and I'll go back to that doc that I was talking about, that I was sharing earlier, is really trying to understand, what your conditions are. Okay, and what do I mean by that? So, let's just say you're given a six-sided die, okay, or even a five-sided die. But let's just say, let's just stick to this example, a six-sided die. What is the probability of rolling a two or a three, a six, given that you have a six-sided die? And put your answers in the chat what you guys think. So, what is the probability of rolling a two or a three given that you have a six-sided die? All right, awesome, Andrew. Yeah, I like your answer. Two out of six. Awesome. Yeah. So, let me go back to yeah, love those answers. So yeah, two out of six would be the right answer. Now, why would that be the right answer? And there's gonna be a lot of like switching windows in this, so that's fair warning there. Um, with given the whiteboard and everything. So yeah, let's go back to the whiteboard. So a two, so we're getting a six-sided die, so two or a three, given we have a six-sided die. Key word here is given. Now, whenever you hear given, that's the conditions that we have. Given is in the denominator. That's a total number, sides that the die has. So anytime you hear given, just know that that will be the denominator. Okay. Let's just say if were to say given that we have a five-sided die, then our denominator will have to be five. Okay. And then a two or a three. Well, that's, one, two possibilities. Okay. So I'll be 2 out of 6. So awesome job, guys. Um, so those are the possibilities. Okay. Yeah, and probability is not too high yield on the digital SAT, but it's really important that you guys get this concept down, um, of probability. Okay. Um, so yeah, throw some thumbs up in the chat if you guys all understood that concept with the probabilities, and I'll be moving on over to combinations. So if you guys don't have any other questions, yeah, I'll be moving on over to combinations now. All right, awesome. So yeah, let me go over to combinations now. And this is also a really this is kind of similar to probability. But let me go over an example um of combinations. And then I know we see that there's medium, mode, and range. I'll go over that later since that's also like its own whole topic. But let me just get over through combinations first, and then I'll go over the mean, median, mode, and range. So combinations. So let's go back to the whiteboard. And I want to throw you guys this example here. All right. And you tell me what you guys think the solution is to this. All right. So we're going to go back to the whiteboard. And okay, so let's say, we're trying to make a sandwich. Okay. And we have bread. Okay. And we have cheese. Okay. This is just one example of a combination. Now, with bread, okay, let's just say, we have rye bread. We have, and I'll abbreviate WW as whole wheat bread. Okay. This is whole wheat bread. And then cheese, let's just say, we got American cheese, um, we got provolone, and then I'll abbreviate pepper jack as PJ. So my question to you guys is, what are the total number of possible sandwiches that we can make, given that, we have to use one, type of bread and like one type of cheese for a sandwich. So, what are the total number of possible sandwiches that we have to make or that we can make here? And yeah, put your answers in the chat to what you guys think is. So the question again is, what are the total number of you know, sandwiches that you guys think you guys can make based on the number of breads and cheeses that we have? So we can only use one type of bread and one type of cheese. Awesome. Yep, 6. Okay, great. Great job. Great job, Charlotte, David, and Trisha. Yeah, so it'll be 6. Awesome. So how do we get that? Well, we have two total possibilities of bread, okay, and we'll have to multiply this. So by the total number of possibilities that we have for cheese, which will be 3, because there's 3 different types of cheese. And this will give us a total of 6 total possibilities. All right. Now, I want you guys to answer this question. So I'll just clear this. Now, let's just say we have an iPhone, or any other phone, right? We're trying to, unlock our phone here. So we got, passcode, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So we have a total of 10 digits. So I'll give you that. So 10, we have total of 10 digits here. And let's just say it's a 4-digit passcode. All right. So we have a 4-digit passcode. So what is the probability um, that we can guess this 4-digit passcode given that we have 10 digits here, all right, and we can reuse any of the numbers. So what is the probability? So it should be 1 over something here. um what do you guys think would be the answer to this? So there's a total of 10 digits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And we're trying to guess the probability of a 4-digit passcode here. Okay, awesome. Yeah, so I like that answer. So basically, you know, there's a total of 10 possibilities. Remember, given that was my key word here, that was my hint to you guys, given that there are 10 digits, okay? So, and we can only choose one number, right? And then if we can reuse that, well, that's another 1 out of 10 for this. So this is for the first digit, then this is the second digit, 1 out of 10 again for the third digit, and then another 1 out of 10 for the fourth digit. Okay. And basically, this could all be simplified into um, 1 over 10 to the power of 4. Does that make sense how I got that? So that will basically be your answer there. 1 over 10 to the power of 4, or 1 over 10,000. That's also a good answer. All right. That all makes sense. Let me see some thumbs up if that all makes sense. There's another probability question here. Hey, awesome. All right, great. All right, cool. So I'll quickly move on over to this second example here with the probability. Now, let's just say we have that same phone example, but we now cannot reuse digits, and it's a four-digit passcode again. So what do you guys think is how can we determine the probability of that? And I'll wait a couple seconds just to see, your guys' thought process here. So again, we have 10 digits, right? So it's 10 digits total, but we cannot reuse the digits. So let's just say I used a one in my first digit. We cannot reuse one again for the second through fourth digits. Yes. Yes, yes, yes. Great. Yes, that's awesome. So yeah, it'll be 1 over 10. So we have a total of 10 now, but since we can't reuse it, that goes down to 1 over 9 times 1 over 8. Essentially 10 factorial, but it ends to basically where we want to end off at. So like, to the fourth digit here. Um so yeah, awesome job. Yeah, so this will be the correct answer. So, if you were to put this into Desmos, so I'll switch my screen over to Desmos. We could see what our answer will be. And it will be, so let's rework this. It'll be 1 over 10. So by the way, another way to use Desmos, it's really critical that you guys know how to use Desmos. Um, I'll type in 1, and then if you hit the forward slash button, that would automatically, give you the fraction. That's pretty satisfying. So then all looks clean there. So 1 over 10 times 1 over 9. It's really critical that you guys also know, to input everything right, making sure to use the parentheses and everything. That way, uh, we're not inputting what we didn't intend to. And then we have this as our answer. So it's a long decimal point, very small possibility. All right. Or essentially, let's just say if we wanted this in fraction form, we could just do 10 times 9 times 8 times 7. It'll be 1 over 5,040. So, very unlikely chance that we'll be able to guess that passcode, basically. All right. So yeah, did that all make sense with the probability question? I'll next move on over to mean, median, mode, and range, and standard deviation, and what the SAT expects you to know of that. So yeah, let me see some thumbs up. All right, awesome. All right, cool. So yeah, let me go back to that doc here, and all right, cool. So as far as these terms go, the SAT they do require you to basically have a solid idea of what the median, the mode, the range, and I didn't write this here, but the average, right? We already went over that average or the mean, right? And then the standard deviation. Now they would expect you to know how to calculate, the median, mode, and range. Those are usually pretty straightforward, nothing too difficult. But the standard deviation, you do not necessarily know how to calculate that on the SAT, but they do want you to know exactly, what it is, and also, what a high or low standard deviation will look like. Okay. So basically, a high standard deviation will be, it's more spread apart. And I'll write this again in our whiteboard. And a low standard deviation is more clustered. So yeah, that's really all they need you to know when it comes to standard deviation. So yeah, let me go back to that whiteboard, and yeah, let me go over with you guys what exactly we need to know with mean, median, mode, and range. All right. So mean, we already kind of talked about this, but what is our mean? And just put your answer in the chat real quick. So I just, really just like a one-word answer here. What is the mean? Exactly. Average. And how would you find the mean? We kind of did this with the exam, average question here, but how would you find the mean? So I'm kind of looking for like an expression here, of some sort. What would we need to do to find the mean of something? Yes. Yes, exactly. So I like, yeah, awesome job. So we'll basically take the sum of all numbers and then divide by the total number of terms. Let me go back. Terms. So yeah, awesome job. Um, it seems like you guys had a pretty good understanding when I went over that exam average problem. So that's awesome. So yeah, that's mean. Now, what is the median? What is the median? And yeah, just try to summarize this term up in a few words here. What is the median? And I'll go over example. Yes, the middle number. That's what I like to call it. So first, it's assumed that all the numbers they have to be rearranged from low to high. So that's the first condition, right? Um, uh, better term here is sort all numbers from low to high. Okay. So let me just give you guys a quick example here. So let's just say if I had 1, 5, 9, 6, 11, what would be my median here? And these are all sorted out from low to high. What would be my median? Okay, yeah, awesome. So yeah, it'll be 9. Now so it's pretty easy if you have an odd number of terms, but let's just say now, okay? Um, oh, um, it would not be 6 because oh, yeah, that is right. It is 6. Yeah, actually, yes, that is right. That is my mistake. Yes, it actually would be 6. Um, because yeah, the numbers weren't sorted. So I guess that was like a trick question. Yeah, so you have to first sort them. So it'll actually be 1, 5, 6, 9, 11. then yes, it will be 6. Yeah. So great catch there, Trisha. Yeah. But yeah. Yeah. So 1, 5, 6, 9, 11. So yeah. Um, so yeah, awesome job. But yeah, it will be 6 in this case, not 9. So yeah, so that kind of segues on to my next question. So let's just say instead of odd number terms, we have even number of terms. So let's just say I have, 2, 4, 5, 7, 8, and then 2, 4, 5, 7, 8, and then 10. So yeah, these are all sorted. So let me just double check here. Yeah, so they're all sorted, lowest to highest. And what would my median be this time? It will be 6 again. Now, you'll basically take the average between these two. So 5 plus 7 divided by 2. So 12 divided by 2, that's equal to 6. Or basically just find the middle number between these two. So yeah, it'll be 6 again. Awesome. Um, so yeah, that's the median. Now mode is pretty easy. What is the mode? And not referring to this question. So like I'm just asking for a general definition. Yes, 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 yes. So it's the number that appears the most. So yeah, so that this one's pretty straightforward. So if I had like 2, 2, 3, 5, we all know that it should be 2. So that's the mode. That's the number that appears the most. So that one's usually a little bit more straightforward with students. Now, let me go back here and let me ask you guys what the range is. So what would the range of these numbers be? And I'm not saying like 2 to 5, not meaning that, but like um what exactly would the range be here? Yeah, I'm not talking about this. Yeah. So subtract lowest from highest. Exactly. So highest minus the lowest. Okay, awesome. So that'll just be 5 minus 2, and that gives us a range of 3. Um, Now, standard deviation. Now, standard deviation is okay. Well, how far apart is the data spread? So I'll abbreviate standard deviation as SD. Is how far apart the data is spread. Okay, so let me give you two graphs here. Um, and then okay, so we got this, and then hmm, got we got one that looks like this here. So like Um, so let me redraw this, but basically we have all the data basically all focused in right here. So which one had the lower standard deviation? So low again just means that it's you know clustered. So this will be clustered, and then high will mean or more spread, more spread. Yeah, so this first one should have the lower standard deviation. So lower, and then this is higher. All right. Does that make sense? The concept of standard deviation. They won't actually expect you to know how to calculate standard deviation, but just the idea of it. That low tends to be a higher, or a more clustered, data set compared to a higher standard deviation where it's more spread apart. So if we're all good there, put some thumbs up in the chat. We'll move on over to the next concept in the for the math fundamentals. All right, awesome. Cool. So yeah, now let's go on over to exponent rules. And I'll briefly, go over these rules, just through the doc here. So, all right. So yeah, I'll go back to that whiteboard again, actually, and let me show you. So we have this whiteboard. So 2 to the power 2 times 2 to the power 3. What will we do to two these two numbers, the exponents? What would our answer be? If you're multiplying two exponents out, what would our answer be? Yeah. So you would add exponents if you're multiplying them. Awesome. So how about this? If I do 2 to the power 4 over 2 to the power of, let's just say 3, so now we're dividing. So if we're adding exponents when we multiplied, what would we expect we would do if we're dividing exponents? Yep. Awesome. It'll be 2 to the power 1, which would be 2. All right. Awesome. So let me go on over to my next exponent rule. This is a little bit tricky here to you know uh, get through, but we got 2 to the power of 2, um, and then raised to the power 3. So what do you guys think will be the answer to this? What do we need to do the exponents here? Yes, yes, exactly. Yeah, so it'll be 2 to the power 6. You'll multiply these exponents. So whenever you have an exponent in the parentheses, and then you have it raised to the outside with another exponent, yes, you'll multiply these exponents out. Okay. Now, I want you to, how would you guys rewrite this exponent here? So if I have 2 to the power of negative 2, how do you express this? How would you rewrite this? 2 to the power of negative 2. What is this also equivalent to? Yes. So it'll be 1 over 2 to the power 2, which is essentially 1 over 4, or 0.25. Awesome. Yeah, so let's go over some more exponent rules here. How about this one? Um, this one's usually a little bit trickier with students. So 2 to the power of 1 half. Um, what can you rewrite this as? 2 to the power of 1 half. So now we have a fraction as our exponent. Let's see y'all's answers in the chat. Yeah, yeah. So now we're bringing the radical here, a square root sign, 2. Awesome. So another thing to keep in mind is, let's just say if we have x to the power a over b, and the SAT, they love to test on this, whatever's in the numerator will go inside the radical, okay? And then whatever's in the denominator will go outside the radical like this, okay? So we're gonna go back to our example here, 2 to the power of 1 half, be 2 to the power of 1, and this radical here, usually when you have a square root sign, it's assumed that you already have the 2. You could write 2 here, but it's already assumed. Um, but yeah, does that make sense? This exponent rule right here. The SAT oftentimes love to test on this. The Whenever you have an exponent that's expressed as a fraction. Right. Um, yeah. So then we also have this really tricky one here, and this will be the last exponent rule. So 2 to the power of negative 1/2. How would you rewrite this? We have a fraction as our exponent, and it's also negative. So how, yeah, it'll be 1 over root 2. Okay, 1 over root 2 here. And yes, yes. And I see you're already going ahead here with, yeah, so we would need to rationalize this number. Now, why? Well, you cannot have a radical at the denominator. So in order to take that radical out from the denominator, you would have to multiply it by root 2 over 2. Now you might be saying to yourself, well, aren't we changing the number if we do that? Well, no, because think about it. All this is equal to 1. So it's still going to be, the same number. So let's do that. 1 times root 2. So whenever we're multiplying fractions, by the way, we'll multiply straight away like that. Another rule I should also mention is, let's just say, we have root A times root B. We'll basically just multiply the numbers inside the radical. So it'll just be root A times B. So let me rewrite this here in different color. So top times top, we got root 2, and then 2 times 2 inside the radicals will be root 4, right? Which is simplified to 2. The square root of 4 is equal to 2. So it will be square root of 2 over 2. Does that make sense? And put some thumbs up in the chat. That all made sense. And then I'll move on over to complex conjugates for my next concept. All right. Awesome. All right, cool. So, what exactly is a complex conjugate? So let's just say, I have, let's say I have an example like this. So 3 over root 2 plus 1. Still had this, this radical here that we need to take out from the denominator. So how do we do that? Well, we need to multiply it by its conjugate. Now, what is the conjugate? Basically, you would need to flip the operation sign of whatever's in the denominator. So if we're adding here, we have to subtract. Essentially, do this. Now, why would we do this? Well, this is based off of the principle of difference of perfect squares. Okay, so x plus b, x minus b, let's give you x squared minus b squared. And if you notice, if we do x squared here, that would take out the radical because we're going to be squaring the square root sign. Okay, so that's really the whole point of doing this complex conjugate. All right, so then you got this 3 root 2. So basically, I have to use the distributive property, right? So 3 root 2 minus 3 over and root 2. So this will just be 2, and then minus 1, which would just be 1. So it'll just be 3 root 2 minus 3. Or you could also like express it like this. Does that all make sense? How you would um, basically take the denominator out here using the complex conjugate? And yeah, put some thumbs up in the chat, and then we'll move on over to our next concept for the math fundamentals. All right, awesome. Yeah, so I guess like one big difference to highlight, this is kind of, a little bit of a tangent here, but the ACT, they love to test this a little bit more, and they would usually test on, using imaginary numbers like I. So that's one thing to keep in mind. So if you're planning on taking the ACT, that is like one thing to consider. You really need to be able to do this well. The digital SAT also likes doing this as well. So this is not as high yield compared to the ACT. All right, cool. So let me go over to the next. concept here in the fundamentals doc. Yeah, so in this fundamentals doc here that I got, um, so yeah, we already did rationalizing numbers. Then now let's go over to the two biggest concepts here, linear equations, and I also want to go over quadratic equations, okay? So one thing I really want to highlight here is that with linear equations, we can express our answers or our expression in slope-intercept form. So we could express our equation like this, y equals mx plus b. This is called slope-intercept form. It's important to know that m is a slope, okay, and then b is the y-intercept, all right? So, and what does the y-intercept mean? Well, the y-intercept is whenever the expression or the graphic crosses the y-axis at x equals 0. Whatever the y value is, whenever x is equal to 0, that is the y-intercept. Okay. Um, and try to think of this logic for me. Um, because the SAT, they really want to test you on if you're able to, basically apply these linear and quadratic equations to real life situations. So apply a little bit more practically. So I'm going to type this here, and I want you to really be able to understand this concept. So for every um, increase in x by 1, y increases by the slope. Or essentially y increases by m. That's another way to phrase that. So for every increase in x by 1, y will increase by m. Now, what do I mean by that? Well, let's just say our slope was 2, and for every increase in 1, that's how much our y will increase by. All right. So that's just another way to think about it. So let's another way to express our linear equations is in standard form. Ax plus by is equal to c. So this is just another way to rewrite our linear equations. The SAT often, really likes to test over on this concept. And one thing that we need to know whenever we're given standard form is we could basically be able to derive our slope or our m by doing negative a over b. So that's one way we could derive the slope from the standard form. And that kind of segues into my next concept here, and that is parallel and perpendicular lines. The SAT, they like to test over on this concept. So with parallel lines, what is one thing we know about parallel lines, by the way? I'm just looking for a few words here for your response in the chat. So what is one thing that parallel lines have in common? So if I had two parallel lines on the graph, what do they have in common? Yeah, so they never intersect. I'm looking for something a little bit more specific though, but that is correct. Yes, they never intersect, but they have the same what? They have the same. There's something that is the same that leads them to never intersecting. Yeah, yeah, I like your answer, Andrew. So yes, it will be the slope. So parallel lines, the reason they never intersect is well, first they differ in their y-intercept. So they're translated or shifted up or down from another line, and they have the same slope. So the lines are essentially like this; they just never intersect. Those are parallel lines. Now perpendicular lines, those are the opposite. Their slopes are negative reciprocals. And let me go back here to the whiteboard here and show you what exactly do I mean by that. So we know that with parallel lines, okay, basically, let's just say we have, you know, these two lines, A and B. Slope of A, so M is equal to slope of B. We got that concept down. Now, with perpendicular lines, we got lines A and B, and they cross at one point. And I want to, this is something that you guys are expected to know for the SAT. And let's just say, if the slope of A is, A over B, let's just say we don't know what the slope of A is, but it's A over B. We would expect that the slope of B will be the negative reciprocal. So it's going to be negative, so we'll flip the sign, and also we'll flip the fraction. So a different sign, and we'll flip the fraction. So it'll be negative B over A. So negative reciprocal. Reciprocal meaning we're flipping the fraction. All right. So that's the relationship between the slopes of the two perpendicular lines, and they'll cross at one point here. All right. Does that make sense? With parallel and perpendicular lines, they love testing on this. And obviously if we have two of the same lines, uh, they'll have infinitely many solutions. So yeah. Uh, Let me just go on over here and we'll move on over to quadratic equations. Um, that is, tested heavily on the ST math. So this is really a high yield concept. I have listed here the absolute value. This is a pretty straightforward concept, but basically the absolute value of a number, of a positive number, I should say, is just, itself. The absolute value of a negative number is just, the sign flipped. So let's just say if it was -5, it will just be 5. And that is because the absolute value is just measuring the distance of a number from 0. So yeah, so absolute value, did test this sometimes, but not too high yield. So let's go over quadratic equations. And there's two ways that the SAT would often, want you to express quadratic equations. That's first in standard form. So ax squared plus bx plus c is equal to 0. And the reason we have it set to equal to 0 is this is usually where, where we'll be able to find our solutions at, or otherwise known as our x-intercepts or our roots. Okay. And it's also important to note that whenever a is greater than 0 or is positive, that the parabola is upwards. Essentially, it's happy. And when a is 0, it's downwards. It's sad. Okay. Also, one thing that you can do that I also find interesting is if you do negative b over a is equal to the sum of the roots that you have. Okay. So that's so you're definitely gonna have to be able to memorize this as ax squared plus bx plus c. That is something you have to know. And then the vertex form. Let's just say you have a vertex or no minimum or maximum point at h comma k. So h will be the x coordinate of our vertex. K is our y coordinate of our vertex. We could do a times x minus h squared plus k. Yeah, and h comma k is our vertex, like I stated. I've kind of already talked about this, but difference of squares. So a squared minus b squared. So it'll be a plus b times a minus b. And one way to find the x-intercepts or the roots, or also our solutions, is we can set y equals 0 and then basically solve. And this is assuming that we already know what our a, b, and c are. And then we could be able to find x and then uh, solve for the roots. Now, how do we find the y-intercepts? Well, we'll set x equals 0 and then see what we get for f of x or y. Now, uh, for the vertex, right, it could either be the minimum or maximum. How can we find the x-coordinate of the vertex? Now, we can do this by doing negative b over 2a, and that's the x-coordinate of our vertex. Now, how will we be able to find our y-coordinate of our vertex? Well, we could essentially just plug the x-coordinate back into our equation, right, that we found earlier. If we know our b and our a, that'll just be negative b over 2a, and then we should be able to find our y-coordinate. Okay. Now, let's just say if we're not able to find our roots, or it's a little bit complex, then we could always use our handy dandy quadratic equation. And yes, you will have to memorize this for the SAT. So x is equal to negative b plus or minus the square root of b squared minus 4ac. Okay, so yes, you will have to memorize this for the SAT math. Um, and there are some problems where they would expect you to handwrite this, but there are, if later on, through your prep journey, you could also find that you're able to basically bypass a lot of these problems of using the quadratic equation by using Desmos as well. So yeah. So it's important to note that inside the radical, the b squared minus 4ac, that is going to be known as our discriminant. Now, why is that important? Well, if the discriminant is greater than zero, then we know that we have two real solutions. If it's equal to zero, that means that there's one real solution to the equation. And if the discriminant is less than zero, so basically negative, we can say that we have zero real solutions, or essentially two non-real solutions. All right. And did everyone understand? I know I kind of uh, went over that a little bit quick here for quadratic equations, but does everyone understand, what is expected to be known for quadratic equations for the SAT math? And yeah, let me see some thumbs up if you guys are, good to go on that. I just have circles and triangles left. So some of the geometry that's expected to be known. And then, yeah, that should wrap up the session. All right, cool. So for the circle equation, this is also expected to be memorized. So x minus h squared plus y minus k squared is equal to r squared. So this is our radius squared. Now, what is h and k? This is our center of the circle. So if our center of the circle is centered at comma k, we could, basically use this equation, the circle equation, to graph out our circle. And you're not expected to memorize the area and circumference equation of a circle or even know this. Now, the reason for that is because I could basically share this another window here. But you're given a formula sheet in the beginning of every exam. And yeah, so let me just share my screen here. Yeah. And yeah. So you're given this equation sheet here. Pull this out from a website, but like you're often given this. So the area, the circumference of a circle, the area of a rectangle, area of a triangle, the Pythagorean theorem, the special right triangles. So there's 30, 60, 90 triangles. So the side lengths for that, the 45, 45, 90 triangles, you're given that, and the volumes of all these 3D shapes. So you're not expected to memorize these. These are given on the SAT exam. So yeah, and then the number of degrees in a circle, number of radians, and also the number of degrees in a triangle. You're not expected to memorize that. They do give you that on the SAT. So that's why I'll, just um, yeah. So that's why I'll quickly go over that. Yes, they do give you the circle angles as well, um, and the arcs. I'm assuming you're talking about the degrees and the radians for that. They do give you that as well. Believe that was on there. Yeah, it was towards the bottom. And the yeah, so okay. So let me go back over to the SAT. I know we just hit the hour, so um, all right. So yeah, basically this is what is expected to be known for circles. A lot of this stuff is already given. And the special right triangles, we got 45, 45, 90, 30, 60, 90, and know that there is 3, 4, 5. So there's no need to do the Pythagorean theorem. If you already know that, one side length is 3 and the hypotenuse is 5, we know that that missing side length has to be 4. So any ratio of that, so 3, 4, 5, 6, 8, 10, 9, 9, 12, 15, any of that, that's going to be, a right triangle. You don't have to do the Pythagorean theorem for that. And then SOHCAHTOA. So sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So that's about it when it comes to the triangles. Now, someone did ask a good question. Do we have to know the unit circle? Now, they actually do ask some questions about the unit circle, but you're not expected to know that because a lot of students actually have not really, finished pre-calculus by the time, or they're probably already taking it. Um, but you can bypass a lot of those questions with Desmos. So you're not necessarily, you don't necessarily have to memorize the or know the unit circle, but it is a plus. So yeah, if you guys have any other questions, feel free to put those in the chat. But yeah, that's gonna be all the SAT math fundamentals. Feel free to, leave a review. Also, like, consider like any like one-on-one coaching if you guys still have any other questions. Um, so yeah, if you are going to be taking a uh, the SAT anytime soon in the fall or even later in the spring, I'm definitely willing to go over these fundamentals again with you and also go over practice exams. Um, so yeah, no problem. And shout out to you guys, that attended this whole weekend. And yeah, for those that came to the reading and writing and the math, awesome job. I'll be hosting another event, and I believe 3 weeks from now. So yeah, there'll be sometime in middle of September. So yeah, definitely feel free to come out to that. Relay the message out to your friends, buddies, or anyone that you know that is going to be taking the SAT, and can think that can greatly benefit from me going over the fundamentals with them and also practice SATs with them. Um, so yeah, if you guys have any questions about like the logistics of, basically my, my sessions, I could definitely go over that, briefly for like a couple more minutes or so before I head off. But yeah, any other questions for ST Math Fundamentals, I'll be staying on for a couple more minutes. But yeah, awesome job, guys. I really appreciate the interactions, and yeah, I'll just stay on for a couple more minutes if you guys have any other questions.